Awesome. I guess, yeah, we are recording now. So, welcome Debarghya for the 16th episode on this interview channel. And sorry to interrupt you on a weekend. I know this lockdown time is a very weird time to get hold of people, even though we are all are working from home. So thanks for that. And before I get started asking you questions, I'll just quickly say a few words about this interview channel for people who are first time here watching what this channel is really about. So I create these videos which has interviews of young engineers who are working into different aspects of computer science applications, be it research, be it applications in a very young startup, or be it any application of pertaining to machine learning. And at various stages of life they must have encountered what really worked for them, what really didn't work for them. And the main goal of this channel when I started for the very first video was to understand it from a student's perspective, because not a lot of current education system, especially because we both have a common thing that we are from India doesn't the bachelor course in India doesn't really focus on machine learning and all those basic concepts. So the idea was what really worked for you, what has been really interesting, what really intrigued you into the various applications of software development or machine learning, to share his or her insights on this channel. So this is what this really channel is about. A bit about me is I am a PhD student at Arizona State University working in biomedical informatics. And yeah, I'll just go ahead and get started with Debarghya. I'll stick on calling you Deedy because I learned that is a much more easier name to pronounce. Debarghya, I might still be mispronouncing it, so correct me if I'm wrong, but I'll stick on calling you Deedy. And yeah, I'll let you introduce yourself. Can you tell us something about you? What are you? What is your background, and what are you currently working on?
All right. So my background has been, I sort of grew up in mostly India, but I spent a lot of time during my childhood here. After I did my high school in India, I came to America for college. I went to Cornell and I did my undergrad and my bachelor's in computer science. And then I focused on machine learning, particularly in the robot planning domain. And then after I graduated, I went to New York to work for Facebook, then hopped over to Google in New York. At Google, I spent some time in Tel Aviv and in Bangalore. And then recently, I decided to make the move to a startup. And now I am at a really early stage stealth company, which is about 25 people. We've been around for a year and a half or so. And I'm based in the Bay Area in Palo Alto.
Awesome. Yeah, that's really great. I mean, you had a quite of a journey. But can you tell us something about your startup? Like, is it really permissible to talk about that? Like, according to your perspective, what are you working on? Is it a research domain, or is it a
I can
development?
talk about the startup. We haven't gone general availability yet, so we're still in stealth, but that's more of a strategic decision. It's not about keeping what we do private. It's more about just strategically when we want to announce our company to the public. What we do is I decided we work on in the SaaS domain where we're trying to build Google for enterprises. So when you work at a company, typically anyone who's worked at big companies anyone who's worked at Google or Facebook would know that there's a tool called Intern at Facebook or MoMA at Google, which really helps you sort through all of the company's information. At a company, you can have information in various data sources. You can have stuff in Google Drive, you can have Quip, you can have your mail, Slack, Salesforce, what have you. With the explosion of sort of SaaS tools that all of these companies need to use for their daily functioning, it becomes increasingly difficult for you to find exactly what you're looking for. And that's sort of where we step in. And there's a lot of people who have tried to do this in over the many years, but it's been quite a difficult problem for many reasons. And particularly it's because it's super permission sensitive. It's extremely, it's a security problems are everywhere. And it's very different from consumer search that you don't have a high volume of queries to train your algorithms on. So the ways you have to think about search quality are quite innovative and very different from Google. So that's my fundamental spiel about what we're doing now.
Wow, that sounds really interesting. I mean, it has a lot of challenges in itself, so it definitely, from an engineer perspective, it really intrigues a lot. But you did mention about working at Facebook and Google. Like, what made you shift from those long-term companies where people might be thinking of settling down, working over there? So, what was the tipping point for you to consider, hey, I want to work at a startup instead of a better job at Google?
So I think there's a couple of points I always say here. One of the points is that when these companies build their brand and build their reputation, they were small, highly talent dense companies that were extremely brilliant, right? Facebook back in 2007, Google back in 2003, extraordinary talent. Everybody in the company was a genius. But that's the talent they've built their brand upon. And then when you start expanding, you have to dilute your talent. You're not going to get 10,000 engineers of that caliber. So as you start growing, you realize the big company things just start kicking in, right? And the big company things include, the politics of how to launch things, what you want to prioritize. Do you want to prioritize high quality engineering, or do you just want to launch products that get users so people can get promoted and so on and so forth? These politics will happen in any big company. I think it's almost unavoidable, but what also is happens is the talent also gets lower and the experience really changes. So the fundamental brand they built upon is not the same over time, which is something that a lot of people conflate, right? Google now is not Google in 2003. The quality of Google engineers now is not the quality of Google engineers in 2003. And right now, when you work on Google products or Facebook products, you're not doing extraordinary work in many regards. There's many teams that are, but many teams are just working on code bases that have already done a lot of the challenges, solved a lot of the problems, right? The distributed systems problems, the hardcore fundamental ML algorithms. Most of the teams are leveraging other people's code to basically build those products. And so you're doing a lot of incremental work, not a lot of fundamental work. That's one of the reasons big companies in general started to be less interesting for me, because I realized that I'm not really thinking very hard about fundamental problems. I'm not really being able to design large scope problems. The only selling point really is you are impacting a lot of users, which is true. You are impacting a lot of users, but the problems aren't fundamentally a little different. So that's one of the main reasons. I guess two reasons. One is the fact that big companies have a lot of other dynamics, and the second being a lot of the stuff is already built for you. So those are sort of the reasons I wanted to explore a smaller space. When you're in a smaller company of really talented people, you see how different it is from big companies. When I first left, realized that I'm really ill-equipped to be in a smaller company. Like all of the skills I thought I learned at Facebook and Google were very like specific to Facebook and Google. They weren't really skills that I could carry forward here. And a lot of the things I had to develop from scratch, like understanding how public libraries work, what are the popular libraries people use, being able to transition really quickly into saying, oh, we're going to do our stack this way, into like, let's do our stack this way because it's way better, even though it's only 6 months. This product has only been released for 6 months. All of those like thinking on your feet, high risk design decisions are something you get at smaller companies. And of course, you can move faster. You have much more say over the product. And at the end of the day, at Google and Facebook, you cannot go to work for a year. Google and Facebook is still going to be around. At a smaller company, if I don't do my work for the week, people are yelling at me saying, where's the stuff? We're going to launch this. We need it right now. And so that sense of urgency, I think I work best in because it really drives me to do my best and to push my limits and potential. That's a bunch of reasons why I did move from a bigger to a smaller company.
Right. Yeah, that's really interesting. But one thing that really, when I discuss with a few of my friends working at big companies versus startups, is they do make a point that while you're working at Google, you learn a lot of best practices. So like you learn from the best that, okay, this is how this should be done. This is how perfectly it's done. But versus work at a startup might be really messy because it might be you as the person, as a Deedy, who would be writing those algorithms or maybe the fundamentals of that particular product. So it might be specific to what are the best practices of Deedy instead of having a lot of people work on it. So do you face that thing? Like, is your current workspace really messy around? Do you have to like have a mental chaos that, hey, I'm just working on too many things, this is too much, I just need to learn? So in a way, if I were to reframe my question, as a young engineer who has just graduated from his master's or bachelor's or whatever degree, would you say that working at a big company first for the few years really helps him or her to learn what are the best practices in general, and then maybe make a switch to a young startup? Or is it still, or would you still suggest that even you would have still done the startup thing just after your graduation instead of working 4 years at Google?
This is a great question. I think it's a really valuable question. Startups, the fundamental aspect of this question is startups are extremely polarizing. When you say startups, it means no one thing, right? Startups can mean really good startup with really strong people, or a really shitty startup with poor, like not that great people. So that's a range. So when people blanket say startups, it's very hard to generalize anything. It could really have a wide variety of implications. For our company specifically, I can say that a lot of the people have had big company experiences, and we, in the first 25 people, have only hired people who've worked in the industry for 2 to 3 years at least. And a lot of the people in our company have been in the industry for 10 to 15 years, right? So these people know what they're doing. In that sense, the best practices are nailed. We know exactly what the best practices are. And I think there's a sense of how much of the best practices do we have to break in order to move faster. And that's always going to be a tussle. And that's one thing I'd like to say. The second thing is whether I would go back, if I were to go back, whether I would choose to be at a smaller company or a bigger company out of college. And that's, I think, a very practically difficult decision. One of the decisions, one of the reasons it's just really difficult is the signaling effect. When you join big companies, it's a signal. Like at the end of the day, 4 years into Facebook or 4 years into Google, Amazon, whatever, you are then someone who's worked at a big company for 4 years. You have some repute, which is understandable by people in the industry. So then if you want to transition to do something else, you have a price tag on yourself and you have some value associated with yourself. Whereas if you were at some no-name startup that didn't take off, no matter how good the people were, 3 4 years you might not have the same experience. You might be treated very differently because people aren't aware of the technical difficulty of what you've done. And recruiters are always guilty of this. No matter what you write on your resume, they're looking at the title, right? Like they don't have time to read all of that. They don't. A lot of recruiters won't understand all of that. So you can say, I've solved the world's hardest ML problems, but at a company they haven't heard of, and then they look at another resume which says Google but worked on a few buttons. For them, it's like, this is Google. This, I don't really know what it is. So that's a pragmatic decision that you'll have to make yourself. And for me, there were other factors as well. I'm also an immigrant on this country, H1B, all of this stuff comes into play. So if I were to do it again, I would have probably joined the big companies still, for all of these reasons. There are a lot of things you can learn at big companies, but it's very difficult to not get complacent. When you're at one of these big companies for 2 to 3 years, it's almost impossible to leave because you're very comfortable.
Yeah, yeah, yeah. The last part really stays. That's one of the concerns that I always have. It's few of my friends who still had plans for doing a master's after graduating from their bachelor's in India. We used to talk that, hey, I'll be coming to US for my master's few years later after getting some work experience. They're still in India, so yeah,
I'll tell you
that's
a good story. One of my professors, when I was graduating, I graduated with a bachelor's and a master's, and I was considering doing a PhD strongly. So I asked my professor, hey, I'm considering doing a PhD, but I want to get this industry experience because I have this offer. It feels bad just letting it go. And, there is money on the table. Why not just do this for a year, let my stocks vest, and then I'll do a PhD, which, works well from a pragmatic standpoint. And he told me, if you take this offer, I guarantee you, I can write it down for you, you're not coming back for a PhD. And I said, no, I will. I strongly feel about this. But he was right. At the end of the day, I couldn't do it. Like it's very difficult to leave a position like that because there's a lot of factors. You're in a big city, you're making money, you have friends, you have all of this stuff. It's very difficult to take all of that away from you and then go back to the academic life. So
yeah, I mean, yeah, well, while we are on that topic, I plan to ask that question maybe later on this video, but while we are on that topic, what were the factors for you to choose a PhD or maybe not choose a PhD? Like you said, you had an offer for a PhD. What made you apply for a PhD? Like, what were your end goals of getting a PhD? Because you will have a set of expectations, right? If I have a PhD, I should be blah blah, or maybe if I don't, it should be something. What were your expectations out of a PhD? And you did mention why you are not going to a PhD, but what was your purpose of going into a PhD in the first
yeah,
place?
I wish I had the more structured version of this answer when in 2015 when I was making this decision, but I'll give you the short form. I when I was so this is the cop out. I'm Bengali. Everyone who's Bengali wants to do a PhD just by default. But the actual answer is, when I was in college, I was doing research at a few different labs in our college. One of the reasons I chose to go to Cornell is because of their great CS research. I was doing graphics research, which was my first interest, and very quickly into graphics research, I realized if I wanted to pursue graphics for my career, I would have to do a PhD. There's really no way to be influential in this discipline without doing a PhD. Then, I also dabbled with machine learning, and I was doing my robot work. And I like doing the work. Like PhD research work is, state of the art, groundbreaking. It's something that no one has done before. I like reading papers. I like reading what people are coming up with, the math behind equations, but behind the actual projects. All of that is extremely interesting to me, and I thought I was reasonably good at it. So those are all the reasons I want to do a PhD. One of the biggest drawbacks and the reasons I ended up not deciding to do it is because you really have to think hard about spending 5 years in one thing that you're really passionate about. And I could not with certainty say that I love this enough to spend 5 years on it. I think back, this was my litmus test is I thought back 5 years ago, was there anything I was passionate about 5 years ago that I still care about as much? And there's very few, like there's very few. So it's a really, really big step to take. And I just don't think I was ready for it. And then the sort of the last point I'll mention is when I saw other PhD students, there's just two things. I guess there's a lot of variation of outcomes in a PhD, and it's a lot of it's luck based at the end of the day. What if your research topic sticks? What if it doesn't stick? For the people whose research topics took off, they're doing great. Some of my friends are now professors and stuff already, so doing amazing for themselves. But for on the other side, if your research topic is just not sexy enough or doesn't stick, you're not going to have as great outcomes. And the best case outcome is to be a professor. It's extremely hard to become a professor, and then you don't really have control over what city you're going to go to, where you're going to live. A lot of complications there. And yeah, I think those were the primary reasons. Okay, sorry, the last point I was going to make was to do a PhD well, the sort of friends I knew who were doing that were very, very good at putting their blinders on and working on one thing for many, many months. No friends, no seeing anybody. Maybe they have a significant other, they'll see them, but they're really good at like filtering out everything else. I'm not that great at that, and for those reasons, like I didn't think I would be a great candidate for the role. So those are some of the reasons I thought about with the PhD.
Wow, these are reflections. I mean, maybe I need to consider because I just got started and I don't know if I have those blinders, but yes, thanks for telling that because I might need those blinders somewhere along the line. But yeah, maybe that is kind of an adaptation that PhD student goes along. But just one last question on that very same note is there still a requirement? Because I knew this because I interned at Philips Labs, and they had a very strict limitation of having a scientist role only to a PhD. So regardless of whatever your publications would be, your work would be as an intern, even if you intern for 5 times in a row, and even if you have great contributions, they still have those limitations. But I know a lot of companies like Google and Facebook, they don't care about the degrees, they just contribute to work. Based on your experience of maybe browsing around through the companies in Bay Area or in general anywhere in the United States, do you see any roles that are specific to PhD that would have a benefit of a PhD student versus a master's or a bachelor student? Are there any roles specific to that benefit of having a PhD
So
degree?
typically, this is how I see things. There are PhD students who graduate from their PhDs and then just start out as your L4 at Google or Facebook, and they're doing software engineering work. So that's one class of computer science PhDs. It's just because maybe their research wasn't relevant enough to the work they're doing, or maybe they were just interested in doing engineering over doing that more of their PhD work. So that's one class. I don't know the numbers exactly, but that's a fairly large class of PhD students. Then there's the other class who are become research scientists. And they are also of two variants. I think primarily it's usually that I did research on something that's fundamentally important to the work I'm going to do, in which case it makes sense for me to be a research scientist. And in some cases, it's like my work is sort of orthogonal to the work I'm doing, but I'm strong enough that I could qualify as a research scientist because PhD students love other PhD students. So they're like, oh no, We trust you. We've been through the same
Yeah.
struggles, so you could be one of us. Although I have seen significantly, especially in bigger companies, that for the research scientist role, it's almost imperative to have a PhD. There are obvious exceptions. There are people who've done very good things without doing that, but I would say almost 80 to 90% of them that I've met have PhDs, so it's almost a requirement. In the smaller companies, I've seen it far less, because when you're a small company trying to get a product off the ground, you're usually doing applied ML or applied AI. You're not doing a lot of fundamental research. It just doesn't make sense for the business. Like, you're not going to have a lab up and running that's just blowing money trying to solve a problem. That's usually not what's going to happen. So in those cases, there are PhD students who work there, but typically not, and they're typically just also doing more engineering work. And lastly, I know at Google, I think it's a requirement. I think Google and Microsoft, for example, have very different philosophies on how they treat their researchers. Microsoft is more like, you do what you want and you publish. That's what we care about. And Google is like, you also have to show that your work contributes to a product in certain ways. And so they require you to do the engineering to back up the research that you're doing and actually deploy that in a production environment for your career growth. And maybe the last point I'll say is, choosing between being a research scientist and a software engineer is, a lot of people just pick research scientist because it sounds sexy and you're doing like neural nets and stuff, which is fine. Like, maybe it is sexy, but in the long run, it's also about your career planning. If you intend in 10 years to be somebody who's maybe like managing an organization or trying to build products, maybe the research scientist role is not perfect for you. But if you are someone in 10 years, I just want to work on hard problems and keep doing research, then it definitely is the right role for you. So that's also a decision you'll have to take for yourself.
Yeah, yeah, those are really great insights. I mean, yeah, it actually answers one of my other questions that I had is what should a person ask him or herself while choosing between doing a PhD or not doing a PhD? But yes, this answers a lot of questions for them. But deviating on a slightly different topic is, how did you get started with ML? Was it your undergrad or like undergrad at Cornell that really put you into machine learning basics and implementations, or was it the internships or maybe some kind of side projects that you did at your leisure time? What was that time that struck you that, hey, ML is really cool or sexy, or I should maybe learn more about it on my own, even if the curriculum doesn't offer me? So what was your tip?
So when I entered Cornell, I was not a CS major. I was actually a physics major, and then I
Wow.
switched to CS. And when I switched to CS, my first sort of I was kind of naive and probably willingly naive. I wanted to be naive about what I wanted to do. That I thought that would make me pick what I really love. And the first thing I liked was graphics, as I said. So I was doing a lot of research in graphics. I quickly realized that maybe this wasn't the greatest thing for me in the long run. That's when sort of ML started becoming a hot topic. The Andering course came out. Everyone was talking about it. Neural nets were all the rage. ImageNet records were being broken. I was reading, Karpathy's blog and stuff like that. That's when I sort of realized that this is obviously something that's changing everything in computer science. And I think the moment that sealed it was, I don't know where I read this, but it was like, computer science was split into so many domains of like computer vision and graphics and this and that, and like, natural language processing, and they all had their own techniques and their own entire disciplines built to like figuring out how to solve these problems, and the various problems in each of these disciplines. And all of a sudden you had almost a silver bullet, which is like, put a neural net on it and it'll do better than everything you've done for 30 years of research. And that is mind blowing. Like, just to think that rarely happens in any industry, right? Like, where a silver bullet just solves a bunch of problems, and it was happening with ML. So that's when I realized that maybe there is something here. And particularly when it came to ML, robots was something that I was just passionate about at that time. I didn't really make a very strong choice. We had a very strong robot lab at Cornell, and that's when I started to take classes and get more into it. I took ML, advanced ML, was reading some of these papers, during my undergrad, and it was fascinating, because computer science has so far not been that mathematical for me, and I do like math, and that's sort of where I started picking it up. And then, as I went to the industry, I sort of saw the difference between the theoretical papers that people read versus what actually happens in practice, which is, very, very different from each other. And that's sort of how my interest grew. But increasingly now, I will say that a lot of people misunderstand, machine learning, where they think that literally everything can be solved with machine learning. And there is a limit, like there is a range of things it's good for, a range of things it's not yet great for. So it isn't really a panacea for all your problems, but it does address significant problems in computer science in a very big way, especially in the last decade or so.
Right, right. And you did mention about there is a vast difference between the theoretical aspects of machine learning versus what the implementation looks really like. So was there a moment like how did you overcome that particular aspect? Because one thing that I realized when I was in my undergrad and I interned for a company called HackerRank where I was working on certain machine learning applications, what I really learned was uh, I mean, the end conclusion of mine was I'm not suitable enough to call myself a machine learning engineer because I had over the time just learned the Medium articles or Medium blogs who were working on very highly curated, refined data sets.
Mm-hmm.
But once you try to overlap those particular learnings to a completely uncharted data set where even the person who is assigning you the work doesn't really know what he or she really wants out of you, he just thinks this is a churning machine that will generate those things. So my question is, did you face any of those kind of challenges, like where it really becomes imperative to understand what really this algorithm does, because it's really important to understand what will this particular algorithm give me if I give the data sets when I have no idea. And if you had those moments in your curriculum or in your internships, how did you overcome that? Like what was your um, what was your, I would say, helping factor that helped you throughout that time?
I'll tell you what happened with me. So when at Facebook, I thought the ML I was doing was pretty not that useful. The product itself was a little broken in the product I was working on. At Google was when I first got a taste of well structured, well engineered pseudo ML solution, which is your entire search quality stack. When you enter a query, what is going on behind the scenes? And search has been something that's been worked on for over 2 decades, and it's the evolution is interesting because when search was younger, in 2003, 2004, even far after that as well, it was primarily based on information retrieval techniques, right? So looking at very basic things, there's a lot of things, but I don't want to go into details. It was based on fundamentally IR techniques. Then when ML started coming up, they realized, oh, we can do better with ML. So they started injecting parts of this stack, ML into parts of the stack, and that really dramatically increased the search quality. We also had very, very rigorous ways of measuring what that meant and how to measure search quality. Very difficult problem. And so when I joined, it was a mixed stack where the first thing you sort of understand is Google knows that if we leverage a full ML solution to all of search quality, we will get a huge increase in search quality. But the reason they don't do that tomorrow or today is because, this is the point that you touched on, understandability is such an important factor in deployed ML models, because you have to be able to reason about what's going on behind the scenes for this query in all cases. Like when somebody asks you, and when you can have a legal lawsuit, you can have leadership ask you, when somebody asks you, why did this result rank here, you have to have an answer. You can't say the model just said so. That's not an answer. So fundamentally, that's a really important, understandability is a really important part. I can't delve too deeply into how Google search works, but they take a lot of steps just to make the very basic model understandable to engineers, at least, if not anybody else. And when you do inject, like deep learning models or natural language models, we make sure that's just one signal into a much larger model. And maybe if you turn off that signal, your quality will decrease, but you still understand the stack fundamentally, even without that signal. So you don't want one gigantic black box to drive your entire network, drive your entire model, because that's not sustainable for a company in the long run. And there's two other aspects of this. One is, for something like search, you have bad user reports and media reports and PR issues, and you need to build a lot of stuff in to not have PR disasters. Like you can't just rank some really garbage web result at the top of a search query and just say the model did it, when you're going to be held accountable for that, because that's how people get information. That's one. The second aspect is iterability is such an important factor with machine learning, where you want to be able to say in maybe 2-3 months time that this launch is better than the last model. And how is it better? You and just measuring some naive quality metrics on top of your entire eval set is usually not going to do the job. You want to reason more deeply about why this is better. What is this picking up that the last model didn't pick up? And that can't just be, I added 4 layers to this neural net and therefore it's better. Like, you have to have a much more fundamental reasoning in order to develop products over time. So those are sort of some of the reasons, some of the ways I learned that applied ML in the industry is very different from theoretical ML, where in the academia world, it's all about breaking state-of-the-art metrics. This is the reval set, this is the metric, I'll break it. So, there's a lot of overfitting that's usually done there. It's not valuable, but it's very different from the industry world. And how I got over it, I was like, going back to the previous question, when you're at a big company, you have people who have been thinking about this problem critically for many decades. So the fact that I had mentors and managers and directors they'll just tell you like why we chose to make these decisions over other decisions, which makes it a lot more clear in your mind what the trade-offs really are and how to look at problems from a lens of a bigger company, which has responsibilities to society and the world and to corporate, to lawyers and all legal and all the stuff like that. So that's my long-winded answer. I didn't have to do much. They just kind of like, you just kind of learn at a bigger company how these things are handled.
Right. I mean, coming to a different question, for that, I'll ask you a very brief question is, can you briefly talk about like, what did you work on while your internships or your jobs were at Coursera, Google, and Facebook? Like, can you briefly tell us about, and what different aspects of machine learning specifically? I'm sure software development was definitely a part of it, but what specific aspects of machine learning that you worked and that you learned? So what the job made you learn about it?
Yeah, sure. I want to preface that by saying, I've always sort of told myself I'm not an ML engineer. I want to make products. That's what I care about. If ML is required in those products, I will build the ML for it, and I want to know that. But my first and foremost thing is I want to build products end to end. And I've sort of tried in every way to push that agenda as much as possible, because I think that will lead to better long-term outcomes than over-indexing on one topic in the long run. But that's a trade-off that people make differently. During my internships, so at Google, I was working on YouTube captions, where we were trying to, it was kind of applied ML and kind of just a product, where we were trying to take the outputs from this model and structure it in a way to automatically generate captions, and then give a flow to creators to be able to edit those captions quickly, because they would have a lot of errors in them, in order to deploy them for their videos. As you know, captions are not only important for people who are hard of hearing or deaf, but they're also extremely important for a lot of just casual users who are just like watching stuff without noise. And back in the day, the captions quality was pretty bad. So there had to be a lot of editing. Over the years, it's gotten much better. So this product is not as useful. It's useful for the manual caption use case, or certain languages where the speech recognition isn't as strong. So that was my first intern project. The second one was at Coursera, where I was building a lot of work to migrate like the old classes to this new structure that they had, and launching I don't know what it was called at that time. They had some code name, but basically a V2 version of Coursera classes. And so that was a lot of core engineering, like back end and front end work. And then at Facebook, I worked there for a year. I was working on places and search. So places, it was everything about the quality of location-based data that Facebook had in terms of places. So how do you create entities out of places? Like Eiffel Tower is a place, it has some lat long, it has some associated metadata. How do you mine that? How do you make sure it's accurate? And then tune that, so not only can people check into those places, but we can also Facebook will leverage that data for, say, their ads framework, or because you want to make better places products. And then we wanted to integrate places into search, which didn't work out so well. No one really searches for places on Facebook. And there was another product called Nearby Places, which was one of the full experiences they were trying to shove into the Facebook app, which I didn't think was a good idea. It still hasn't really taken off. So those were sort of the products I was working on at Facebook. One of the reasons, I didn't mention this earlier, but one of the reasons I left was because I just didn't find those products extremely valuable. I couldn't see the utility to users. So Google, I did, a lot of it was specific to the team and not the company. And so, and Google, I worked on search quality for half my time, and then the rest of my time I switched to sports, which was amazing. Like that was the coolest thing I ever done. So I was working on building cricket for Google search, and now,
Oh,
and so that was sort of everything I've done.
right, right. But yeah, the question that I was trying to come to on was in terms of getting expertise in machine learning aspect, how would you rate like if I wanted to call myself a machine learning engineer down few years of the timeline, would I say a job or maybe a startup or maybe a MNC or versus a small startup can teach me better at getting good at it, or versus a PhD or a master's can be really helpful? How would you rate them? Like what should be my
ML engineer is
choice?
a fairly broad term, but if you mean ML engineer to mean more applied ML, so what that means is you're usually not working on the core of developing, how what models are going to come up, or you know, developing core ML frameworks. Then that's a research scientist role usually, even though there are ML engineers there as well. Then there's ML engineers who do mostly applied AI, and when you do applied ML, you're basically taking models and then figuring out how best to use them to solve a certain use case. So depending on which one you want to be, you may or may not need a PhD. Um, in my opinion, like I'm not an expert at defining what an ML engineer is, but in my opinion, what I've seen the best ML engineers generally have a strong understanding of the fundamentals of ML, of course, but they also have extremely strong engineering sense, and they value pragmatism over everything else. So they're very like the weaker ML engineers are this is sad because I know you're a PhD student. The people who just come out of their PhD and have to realize how the engineering world works, they have some problems and they struggle. But people who can learn to execute and in 2 or 3 years time learn how to execute on viable real world solutions with their ML expertise become extremely valuable. And so I'll give you some examples. Some of the best ML engineers will tell you in a meeting straight up, this is not going to work. They'll look at a solution, they're like, this kind of model on this kind of corpus, given this training size, given our latency requirements, not going to work. Those are the best engineers. The ones who save you like 6 months of time are the best ones. Who will tell you what will work, who knows how to reason about what will work, and will tell you the pros and cons, but give you a straight answer. I think that's what I've seen is the most valuable. Because if you go into the rabbit hole of trying to inject poor solutions where they're not required, you can spend 2 years and have very little output.
Yeah. I guess, yeah, the last point that you made really makes a lot of sense, because I guess if you hire a machine learning engineer, his only not only, but one of the major contributions would be to have a great outlook that, hey, what thing will work or which will not work.
I'll give
But
you to follow up on that. I want to say two things that I just realized are very important that researchers don't look at all is cost and latency, and actual like feasibility of infrastructure. Those three things are obviously fundamentally important for a small company. There are certain solutions that just won't work because you don't have the money. There are certain solutions that just won't work because inference time is way too slow, and there are certain solutions that won't work because we don't have enough engineers to develop all this infrastructure. We need to plumb everything in and to clean the data and to do all of this stuff. So those are just things that you have to be more pragmatic about when you're an ML engineer, which is very different from in academia, where you're not thinking about all of these things necessarily.
right, right. And just one last question on that note is, although this might not be your first-hand experience, but I just wanted to probe you if you have any tips on that. What I have learned is while I have been applying to a lot of machine learning internship positions, or maybe even full-time positions that I have been applying after my bachelor's and master's, one thing that I realize is maybe itself the company doesn't have a very clear definition of what the ML engineer umbrella should be doing. Because for software development, even the person in the very first round of interview can have a great set of duties that they might say that, oh, hey, you might be working on this particular product or certain pool of products. But what I felt is machine learning in any company doesn't have a very clear set of definition what you might be expected to work on. And the interviews, even I have been going through, I have been through 6 rounds, even at Google. I can safely say at Google, I was down to the 6th round of interview, and they had a very, very different set of interviews that I found that, hey, what are you really expecting from me? Like, are you trying to probe me from a graph database? Are you trying to probe me from a neural network perspective? I cannot provide you all kind of expertise in just one person. So the question that I'm trying to come to is, what are the expectations that you might feel that, hey, you're working at a young startup. If you wanted to hire a machine learning engineer, what he or she should have in his profile, and what you would test him or her on? That, hey, I at least need this much insights. Like, this person should be able to at least tell me what the data really looks like, or maybe do you want the person to at least run a model? And the second question to this, the second question that you might, if you like to answer, is how this might differ from big companies. So I call three categories: the big companies, which are like highly successful and they have very mature products like Google, Facebook. Second are the small startups, like who have good amount of fundings, who have good amount of popularity. They just don't have um, the IPO levels popularity. And the third is a stealth startup that you are currently working on, which have no public visibility, but they might be working on excellent products. So yeah, those two questions, like what are the expectations in these
I'll
three
preface that with
categories?
saying, having worked in big companies for a long time and having interviewed at these places, interview processes are traditionally just broken. Like, if you look at what happens behind the scenes, the person interviewing you really doesn't care. He's been called basically out of a duty that he doesn't get rewarded for in any way. He's basically told, "Hey, are you free 2 p.m. on a Thursday to take somebody's interview?" This is his resume. And he'll say, "Okay, I guess I have to." So he takes it, and then he's like, "What is the question I usually ask? What kind of interview is this? Is it a software engineering or ML interview?" If it's a software engineering interview, he will come up with the question he typically asks and he'll just ask it. He has really no context of what your other interviewers are asking. Besides, maybe he knows the question, so there's no duplicates. Even that falls through sometimes, but that's about it. So it's not surprising that like you're asked like a complete random set of questions and you're like, what do you want from me? I've had that experience with big and smaller companies when I was interviewing, and I just think it's a poor process. And I'll tell you why it's a poor process. It's not very interesting. It's just because hiring is just one of the 100 things that companies have to do. And hiring is run by recruiters, but engineers need to get involved, but engineers have no incentive to participate in this. So that's why it ends up being a hodgepodge of situations. Now, coming to the ML engineering specific thing, with ML engineering, typically it just, all it means is you're going to have 4 rounds on site, two ML, two engine, two software. That's fundamentally all it means. They're not really thinking about this from a harder level of, what should the person really know? Like, they're not really delving into it that much. They're trying to productionize an algorithm for recruiting an ML engineer. And this is how you do it: two ML rounds, ask these sorts of questions; two engineering rounds, ask these sorts of questions. If they pass, then they pass, then they can come. That's how it works for most big companies. The smaller you go in terms of companies, the more they care about what we actually are looking for, because every incremental engineer is much more value to them than it is to like a Google or Facebook. They can make one like wrong hire, doesn't really matter, but for even a 200-300 person company, that matters. Like, you want to think more rigorously about this. So I've seen in those situations you get interviews that are much more well-rounded. Even in our company, I can safely attest that we'll have maybe a similar style of interview. We don't have an ML role. I'll get to that later, but we'll have several that style of interviews. But when we're discussing feedback, we are far more empathetic and far more like delving into, do we really think this candidate is good? It's a us and a candidate is a very personal relationship where we care about working with this person for a long time. We really want to make sure that, is it just that we asked a question the person didn't know on the day, even though they're very smart, or is the person lacking fundamentals? So we'll ask very pointed questions about how did the person approach it, or how did the person write this code? Was it just a mistake, or was it something he knew and clearly was just a little rough on the edges? And really try to delve into what this person's background looks like from the signals in the interview. Um, so now going back into the ML engineering part, we're a small company, and at our stage, even though our product is, machine learning is a critical part of our product, we don't hire specifically for an ML role because it doesn't make sense. The software engineers we will hire typically have the caliber to understand, read research papers, learn state-of-the-art techniques, and implement them in a way that we don't specifically require somebody with a PhD background, where the downside would be they don't know enough about engineering to be productive, and the upside is limited. Like, maybe they know a lot about a specific domain that can be valuable, which is it's limited given the fact that they can't really make that and transition that into an actual idea, an actual working production code. As you go, as you start growing and you get to a stage where you have a team, we don't have teams, right, at our company. We're just a bunch of people with no reporting chain, nothing. When you start having teams and hierarchy, and then you have a team that is working on an ML part of it, like one classic example is, say, in Uber, you're working on matching riders to drivers, and you have an entire team focused on that. That's when you reach the specificity of, okay, let's hire a guy who just knows a lot about this, and that'll help us. And that's just a scale thing. So as you grow, you have more specific roles, and then you want to hire and target for those specific roles. It's very difficult to say broadly what an ML engineer should and should not do. It's too broad a role, and really depends on the specifics. I it's the same with software engineering, right? When we do apply a blanket term for software engineering, but there are obviously software engineers who are greater at front end stuff, mobile stuff, back end stuff, and so on and so forth. So with ML engineers, the specifics do matter a lot. I don't know if that really answers your question. I sort of went.
Yeah, definitely. It does answer. Yeah. That's really interesting. I mean, this is really interesting to me on a personal level because they are really great insights. And one other question that I particularly had, and this was one specific for you, is just few months back while I was graduating, I had, even though I was focusing on getting a PhD over here at ASU, I did apply for a product manager role because I still like the idea of the aspect of designing a product from a very coming from a research background. I can put into a lot of I can put my efforts into designing a product, knowing what would be the viability of a particular product. But one thing during the interview process that I inherently realized is I don't have the skill set of a product manager, because even my undergrad in India or my master's over here at ASU didn't have any courses that would actually help people understand that, hey, this is like, you made great products, you are great at coding, you are great at research, you can do the you can just beat any of the results, but still the idea or the aspect of designing a product is something very different, and this is not taught in schools, at least from ASU and my undergrad college in India, that I can definitely say. But I did read that you have a bit of experience of leading a product, or at least a product managerial role. So that was the only interview I realized that, hey, I don't have the skill set. It's not the interview process that's broken, it's maybe my skill set that's broken, and I frankly realized that. So
I'll ask you, can you delve into why you think that is? Like, what do you think was missing in your skill set that the interview revealed?
so I'll just blankly say which the company, like I interned, like I interviewed for HackerRank because I interned few months back at HackerRank, and over here at the US office in the Palo Alto, they have a very nice market, like don't have the engineering role, but they have the product managers and marketing and all those things, all those related domains. And they asked me a very specific question that, hey, if we were making a product for a particular client, and if we have this much amount of questionnaires for the interview process, because HackerRank is an interview company, right? Like you use it for a recruitment process. Then how would you deal with clients who are asking certain things? And these are the candidates that you have, the pool of people who are your active users. And how would you deal with creating a product that is specific to a certain application that they asked? I don't remember what exactly the person did mention a very nice use case scenario for me to understand. But I frankly thought the answer that I gave was not something HackerRank would want me to implement in real world if I was a product manager, because I couldn't understand what, like, it involves a lot of things like expectations from people versus from a revenue perspective, like because at the end, the company who wants to hire HackerRank for their work really needs to have a good outcome, right? And even HackerRank has to profit out of that particular product. So those things I couldn't think of those things. I don't know if it comes with experience, of is there a preparation technique for that. So I wanted to ask you, like, you worked over there at Google, was it? Correct me if I'm wrong. It was the Google's job that you were that you had your product manager role. How did you prepare for that, or like, what are the key aspects? Like, again, what is the recipe of a making of a product manager role? Is there a set of guidelines already out there that, hey, you need to do those things to call yourself a product manager.
So okay, I can talk a little bit about this. So my background was at Google when I was working on the cricket project because we didn't have enough product managers to staff the entire project. I was filling in for the product manager role and doing what the product manager would do. I will preface this by saying I think this is a product manager has, and I'm not a very experienced product manager, but largely from what I've seen, they have two functions. One function is largely administrative. It's more like, is everyone doing their deliverable and can we put all this together and actually get the product out? So it's more like literally managing a bunch of different teams from sales and marketing and here and that, and making sure everyone's work is coming together to align with the eventual goal of launching this thing. Then there's the aspect of actually making product decisions, like how are we going to solve this problem. This is a problem where there's clear trade-offs between organizations, like we're not going to make as much money, but engineering wants this, sales wants this. How am I going to balance all of those things and make everybody happy and get the product to be successful? Eventually the goal of product manager is the product should be successful, right? And you can define metrics and all of that, but that's the eventual goal. Now, I have kind of a controversial opinion about this. I think for most companies and most roles, there is no need for a product manager. So this is, I'll validate this with when Apple came out with the iPhone, there was no product manager. Before 2003, there was no product manager, right? Product manager was a role that came up that Marissa Mayer came up with at Google. But before that, there was nothing called a product manager, but products definitely came out, right? So, and they were very successful even before that time. So what was going on then that's not going on now? What changed? Before, what used to happen is engineering would make the product decisions, and that made sense because engineering knew what the trade-offs were the best. Because you're making an engineering product, you are the most well aware of the trade-offs, and you get the input from sales or marketing or business or whatever, and then leadership is the one that makes a lot of those trade-offs as well, and gives more of the engineering onus to the engineers. And it's a balance of engineering and leadership that's making those decisions. Somebody has to make those decisions, but it's leadership and engineering versus a product and engineering. When product management as a role came up, I see it as extremely broken incentives, because now what you have is you have engineers, they report to an engineering manager. They work with a product manager who's telling them what to do, but they don't have to do it because they're reporting to the engineering manager. So who do you listen to, the engineering manager or the product manager? Why aren't they aligned? Like, aren't they supposed to do the same thing? And then your answer will be the engineering manager is a people manager, which I don't really know what that means. It just means making people happy. But you're a people manager, whereas the product manager is the product manager. I don't understand why that's the case. I think the engineering manager should be responsible for everything going right because you're managing the engineers. And the product manager, if anything, should be the one organizing and making people, like making sure everything is done. Now, there are many caveats. There are many cases where product managers are extremely important. It really depends on the function of the business. If you're working on an ML team, I think the product manager is absolutely zero value. Like, you should really, in most cases, there's no value. The ML guys understand it. These guys understand it better than you. You're never going to understand it. So just let them do their work and make the engineering manager responsible for the eventual outcomes. In some cases, though, where, let's say an Uber is a good example, where the business is technical, but it's a lot of it is actual, like, organizing between various stakeholders outside the company, where you have drivers, you have this, you have so there's many other things to balance off. That's something that engineers don't have time or expertise in, and you should hire a product manager that manages to balance all these stakeholders and make sure we're doing the right thing and communicate with them, understand their problems, come back, report the problems, try to design ways that we can get around it. So those are the two cases where I think, yes, we should need a product manager, and no, I don't think it's required. However, modern day product management has sort of devolved into, here are the people who will do the talking and here are the people who will do the coding. And that I don't agree with. It scales, which is great because there's a lot of engineers who aren't very good at thinking about product. But I think you should be more rigorous with your engineers. I think all engineers should be developing product skills and should understand the implications of what they're doing. You're not in a black box where you're assigned Jira tickets and you're just going to file and you're just going to get rid of your bugs and then you're done for the day. That's like I think it's a very reductive way of looking at what engineering is. I think you are definitely responsible for the pros and cons of your eventual design decisions and product decisions, and that should be on you. You're the engineer. So coming back to product management skills, today, the interview process is designed in a certain way. I think it's extremely broken. And the more subjective the interview becomes, the more broken the process becomes. And product management is extremely subjective. In a couple of hours, I don't know how you're going to understand whether this person is good at thinking about problems. If you're hiring an engineer, it's implied that they're good at thinking about problems, so you should just make them be the product managers anyway. Um, anyway, that's my opinion. I've also done product management interviews. I was good at some of them, not good at some of them, and I realized it was a lot. It felt like me. A lot of the interview was showing this illusion that you can think in a structured manner, which is completely an illusion, because everyone who does well has studied for them. They know the questions, they know how to think, and they know how to break down the problem and then solve it step by step. But that's something everyone can learn. By and large, I think product management roles just go to people who speak very well, who are able to study and structure these problems down into their core components, make reasonable assumptions, and come across overall as an impressive person that people would listen to. If you hit all of those goals, then people will get hired as a product manager. But I don't see the value. So that's
Yeah.
my spiel.
Yeah, that's really interesting. That's at least good for me to know that, hey, maybe PM role is something you learned over the experience. But yeah, I do agree. Based on my very limited experience of working at big, like maybe just companies, I won't say big companies, but yes, the whole idea of having a peer PM versus having a engineering manager really doesn't really add up unless it's a very big company where they have lots of products coming in, lots of features going out every now and then. But yes.
One other thing I'll add is that at the companies I've worked with, the line, and I think one of the reasons why, say, Facebook and Google engineers are regarded so highly is the line is very blurred. I've noticed this especially in India, where the lines are very strict. Like, you're an engineer, you will code; you're a product manager, you will manage the product. And you can't really, it's looked down upon to like merge those lines. But here at the companies I've worked with, and even the company I'm at now, when a product manager makes a decision, an engineer definitely has the right to say, no, that's the wrong decision, we can't do that, or we have to rethink the way this is going to work. And you almost work in unison with the product manager, because you both want the product to be good. And that is not the same in all companies. I like that.
But yeah, but that's I guess the ideal thing that most of the companies should be adopting to, that like a combined opinion is much definitely better, because a PM might just say that, hey, I want this, but that's not feasible from an engineering perspective. So yes, that's really important. But yeah, I'll just conclude by the very last question that I normally ask for everyone, but feel free to have your own opinion on this particular is, what do you think are the current trends in ML? Like, you might be seeing a lot of, because you're working at a startup, you definitely browse a lot of products from a young startups person's perspective. So, like me as a student, I won't be having the access or maybe the resources as to probe along what are the startups working on. But what do you think a lot of young startups or companies are trying to focus on from a ML perspective? What is the product? What is the next big thing people are investing the most on to develop it from an industry perspective? And this comes from a perspective of knowing knowledge for a very new beginner. Let's say if I'm a person who just found ML is very sexy, I want to learn, but hey, there are 20,000 applications already out there. Which do I choose? Everyone could be equally interesting. I mean, NLP, computer vision, medical, robot planning, reinforcement learning, they are all great. I mean, they have the sexiness of ML lies in all of them. How do I choose? And the easiest ways to understand, let's say Google is working on search algorithm. I'll try to focus my efforts on that. But in your limited experience, like in your, I won't say limited, you have a broad sense of experience. Where do you see the trend? Like what is the trend people are focusing on from a ML application?
I think it's the wrong way to look at it would be to say what are the big companies working on and work backwards from there, because often the big companies are just working on stuff that helps them. So Google and Facebook need NLP because a lot of their products use natural language. The way I would frame the question is, what can ML not do now that would be really valuable for ML to do? And I think the closest I've seen in terms of the really, like, what the really big thing in ML is how do we get generalizable models, right? How do we train on a completely different data set and be able to apply that model to a completely different domain? Obviously, there have been pretty stellar advantages of how GPT-3 works. There have been some pretty interesting examples of few-shot learning that are extremely popular. I think those anything that heads towards the direction of general AI is something that I think is interesting. And whether it's hot or not, I don't know, but it's definitely like the future of AI is how do we do that? How do we limit training data and learn more? How do we actually gain insight and knowledge instead of just having billions of parameters and being able to do some high level generalization? How do we understand meaning and stuff? I think that's extremely important. But that's more of a large and theoretical domain. In terms of the more applied, what things, if we solve, can lead to an extremely big tangible difference in how we lead our lives. And I mean, that's obviously, I think the go-to is driverless cars. I think that's what everyone talks about, everyone does. Funny story is when I was leaving Google, that was my choice was between Waymo and this, and for various reasons I didn't take that. But extremely interesting stuff. I think I don't know if there's a single application of ML which has such a high threshold of precision, more than driverless cars. And I just don't know how they're going to figure that out. Like, even if you look at search, for example, you can go wrong in search and no one's complaining, right? It's a very low stress problem. But with driverless cars, it's definitely not the case. And you can go to 95, 99, 99.9. But what about the rest? Is that enough? How do you figure out what goes wrong and who's responsible? I think that's extremely interesting from both an engineering and a societally, like, legal problem. Like, how do you deal with that? So those are the two I'd go with, but I don't think that's the most novel insight. I think everyone would pretty much say these things.
No, no, that's really interesting. I mean, to know what really, because you made a very important point that understanding that computer vision in driverless domains is highly sensitive. I mean, just a very slightest of the mistakes really makes a lot of difference. But if Netflix gave me a wrong recommendation, I won't be killing or maybe suing in a Netflix for that. So that's a great deal to understand for a lot of beginners.
And the
But
funny story is the other day I was driving the Tesla, and I was really excited to see whether all the driverless features worked. And they have a feature called auto park, right? So I was trying to back in. I'm pretty terrible at parallel parking. I was trying to do this parallel parking, and it sort of just pops up on your screen where it says, "Do you want to auto park?" And I'm like, "Yeah, let's try it." Like, I can't do this myself, so I press the button, and it does the most disastrous auto park job I've ever seen, where there's these two cars like here and here, and I'm trying to back in into the spot, and it backs into the spot, but it's a meter and a half away from the curb. So half of my
oh,
car is still on the road, and I'm like, ML, you need some work, like, these Tesla engineers are, they
oh,
need to improve. So it's not like the engineers are bad or anything. It's just, it's a tough problem. And I don't know
yeah.
why it went wrong in that case, but I think every few months, I think we're closer and further than we think. And it just keeps oscillating. I really don't know.
Yeah, I guess that's what happens when you deal with the real world data, because not a lot of places have the same structure. And but when you talk about parking, I have at least seen the summoning videos like that. I don't know which Tesla has that feature or maybe what the details are, but there's a feature where you can actually summon your car, right? I mean, that
It's
works
pretty bad.
perfectly cool. I don't know. I have at least seen one person doing that, and I was like, wow, it's
So
Tesla is
there's
doing great.
there's the way it works. So there's summon. The basic summon is just back and forth. It's like a remote control for your car, which is cool and it works as intended. The smart feature is auto summon, which is you can technically be standing like at a Walmart at the door and it's raining and your car is somewhere in the parking lot. As long as you have a line of sight, it says that if you call auto summon, it'll come directly to you. But
Uh,
if you look at videos on YouTube, it's a disaster. Like,
oh, is it?
it doesn't move like a normal, like a human driving a car. It just moves like a really bad, like those robots we had as a kid where it would make chaya chaya noises and like run into random things and then just try a different direction. It just ends up like that. It goes left and then it realizes there's an object. Then it goes right and realizes there's an object. And then it's not as great as you'd think it is. I'm sure it's a complicated problem, but I'm excited to see where they go. I'm bullish on them in the long run.
Yeah, at least from a person who is fairly interested in computer vision, I'm really optimistic about it. But a lot of people are really skeptical about it and critical about it. But at least I have seen my models training out and they are terrible. So I'm just complimenting those people who are working at Tesla that, hey, I know you are doing a great job. But yeah, the real world is not something that really works on your fingertips. But yes, I'll just end this video by a very last question, which is a very broad. I don't know if how you would answer this is, what would be your tip to any person, any computer science person, regardless of machine learning enthusiast or just engineering, like just a normal engineer? What would be your tip to that person to how to learn things and how to achieve whatever goals he or she has? And what is your way forward? I'll keep this narrow down to computer science because since that's your background, I guess we both agree on one thing, is that at many places education systems interview process are broken. But how do you still jump and skip those things? Like, you might not have the access to the best course curriculum because I mean, fairly Cornell is a very great college and they have the most modern education, but I'll keep this open to a lot of people who are from different backgrounds. How do you, any general tip, and feel free to
Naively,
be.
my general tip to anybody that fits everything is just be curious about problems, and that's it. Like, don't follow something because it's hot. Understand it, understand the pros, understand the cons. Be curious, delve into anything. Just try to be curious about understanding why something works and how something works. And I think that advice will get you a much longer way. If you over index into something that's just hot, you're not going to be satisfied 5 years from now. And that's just not, it might not work out and you're going to be left in a weird place. But if you like problems, trust me, you're not going to be dissatisfied ever because problems will keep happening. And so I think keep an open mind and be curious about problems. It's somewhat idealistic of advice because I realize, sometimes you're in India, you have financial hardships, you really just want a career, you want to be stable, you want to not have to think about all these things, and so you're thinking, what's hard, how can I pass an interview, how can I get this job? I know that's really stressful, but you should keep the larger picture in mind and just focus on being curious about solving problems. And if you can do that, you'll be a good whatever, not just an engineer, you'll be good at everything. So I think that's just my blanket advice.
Yeah, that's really great and that's really insightful. Okay, I'll end this video. I'll leave a link to your homepage in this description of this video for people who have any specific questions. To based on this video, they can reach out to you and be more specific about the question. So that would be a really great help to all of them. But apart from that, I'll thank you a lot for this. I personally like this particular interview a lot because I guess there were a few bits about insights that are useful to me too as a PhD student. But yes, thanks again. Thanks a lot for doing this video, and I hope you also liked it.
Yeah,
So
thank you, Jeff, for inviting me. I had a really good time chatting.
thank you. Bye bye.
All right, bye bye.